Hello everyone, and this is Mr. Regner with a review of Chapter 6, Equations. Today we'll be taking a look at our study guide, and I'll be completing the study guide along with you. And I just want to let you know this study guide is a bit of a beast. And so rather than try to tackle all of it, I want to make sure that I kind of run through over everything with it quickly here. So first, you'll notice like page 1 has questions 1 through 10. Page 2 goes through 14. Page 3 has 15 through 17. And that's actually the end then of part 1 of our test. The next page, if you flip it over, it starts over with number 1 again. So number 1 through 7 is actually part 2 of the test. So our test is actually broken up into 2 parts over chapter 6, over equations. So we're going to kind of look at our study guide here as one big piece today. But just know as you prepare for your test that we will have our test broken into 2 different parts. So let's get it started here, starting with numbers 1 through 4. And I say that because these are all matching questions. So as we take a look at it, we want to read carefully the words that we see here and try to match it up with one of these options from the right-hand side. So starting with number 1, it says the quotient of a number n and 2 is 12. So a couple of key words here that I'm going to actually underline. First, I have the word quotient. Then I have n, 2, the word is, and 12. So quotient, I automatically know that I'm going to be dividing. I'm going to be dividing n and 2. So n divided by 2, and the word is always means equals. So n divided by 2 equals 12. That's n divided by 2 equals 12. Now if I look over here, I happen to see n divided by 2 equals 12 right here, letter D. So I'm going to put letter D there. Number 2 says double a number n is 12. Again, there's that keyword is, which means equals. So I know it's going to equal 12. Double means 2 times a number n. So 2 times a number n. I don't see it up here, but look at letter A. It says 2n. That 2n means 2 times n. So letter A is my answer. Look at letter number 3. 2 more than a number n is 12. There's that keyword is, which means equals. So I know it's going to equal 12. More than, those are keywords that mean plus. So 2 plus n. If I look over here, 2 plus n, I see n plus 2. It's the same thing because of the commutative property of addition. So letter C works for number 3. I only have one left, but just to make sure, it says 12 is. So it's going to say 12 equals 2 less than a number n. Less than means minus. So I'm looking for something that says 2 minus n. So let's check it out. Oh, I'm sorry. Ooh, I messed up already. 2 less than a number n. Less than, we kind of think that switches them around, the order, because it's 2 less than n, not 2 minus n, but instead n minus 2. I'm only 4 questions into my study guide and I've already got an error. But I'm glad I caught it here so that you can avoid it for your test. So it's n minus 2, and look at that. There it is, letter B. Remember, less than, it's kind of like we're switching the order around. Let's move on to take a look at number 5. Number 5 says, tell whether b equals 15 is a solution of b minus 6 equals 9, and show our work to justify. So I'm going to take this original equation, and I'm going to do a couple of steps. My first step is to substitute. I'm going to take out b and plug in 15. Now I'm going to solve. Now if I look at this, I can only solve this expression on the left, because on the right it's already 9. So I know that's going to drop down and be 9. So I have to think 15 minus 6, well, that equals 9. So now the last step is to answer, and I'm going to say yes, because 9 does equal 9. So I've justified my answer by showing my work. Let's take a look at numbers 6, 7, 8, and 9. They're all really similar. They just say solve the equation. So when we're solving for an equation, we want to follow the steps that we've learned about, and that is to use our inverse operations. And in the end, we're just going to figure out what the variable equals. So I look at number 6. It says x plus 7 equals 12. Well, I'm going to look at whatever I see next to that x that's keeping it from being alone, and it's plus 7. So I'm going to do the inverse operation of plus 7, and I'm going to subtract 7. If I do something on the left side, I have to do it on the right side. The exact same thing. That's minus 7. So these 7's cancel out. I have x, and x will equal 12 minus 7. That's going to be 5. So x equals 5. Now, I always want to check my work here, and I can guarantee I've got this right by just doing what I did up here in number 5, that's substitute and solve an answer. So let me plug in where that x was, the 5. So I have 5 plus 7 equals 12. Let me add it up. 5 plus 7, that's 12. And look at that, 12 equals 12. So I'll say, yes, that's true. I'm guaranteeing that number 6 is correct. I'll do the same thing for number 7 now. It says n minus 1 equals 10. I'm going to look here and see what's there with the variable n, keeping it from being alone, and it's minus 1. So I'll use my inverse operations, and I'll add 1 to both sides. These will cancel out, so I have just n, and then 10 plus 1 is 11. I'll check that by substituting, and it turns out that 10 does indeed equal 10, so I know for sure number 7 is correct. Right? No one should miss these because we can always check them and make sure we're right. Look at number 8. It says 4 times p equals 32. So the thing keeping that p from being alone is 4 times. So I'm going to divide by 4 on both sides. So that's canceling out the 4's. I'm just left with p. And then 32 divided by 4 is going to equal 8. I can plug in that 8 for the p. So 4 times 8 equals 32. Let me just double check that. 32 equals 32. That's a big yes. So I'm guaranteeing number 8 is correct. I'll move on to number 9. It says k divided by 4. And if you need to, you can always rewrite that as k divided by 4 equals 9. Sometimes people like to rewrite that. It's easier to see. So what's there with the k that's keeping it from being alone? This divide by 4. So I'm going to multiply by 4 on both sides. That cancels out the 4's. I'm left with k. 9 times 4 is 36. Let me substitute that in now. So it says 36 divided by 4 equals 9. So it turns out that 9 equals 9. So I'm guaranteeing that number 9 is correct. Again, that's the steps that we want to take for numbers 6 through 9. They're very easy problems, and you can guarantee that you're correct with all of them. So there's really no reason to miss those ones. Let's move on to number 10, which is really kind of the same kind of question with an added element. So it says if y minus 4 equals 6, so it's saying that this is a true statement. We have to solve for y. And then it says what's the value of 3 times the sum of y plus 8? Well, first I have to know what y is. I can solve this, then take that value of y and plug it in here to solve that. So this is really like kind of a two-part question. Let me start here. Y minus 4 equals 6. Well, if I want to get y alone, I'm going to have to get rid of that minus 4 by adding 4 to both sides. That cancels out here. I'm left with just y, and then 6 plus 4 is 10. Again, I could check that and say 10 minus 4 equals 6, and that certainly is true because 6 is equal to 6. So if y equals 10, which is the answer I found here, now I'm just going to substitute the value of y the value of y up here. So I have 3 times y plus 8. So let me take out the y and plug in 10. Now I can just solve. So 10 plus 8 is 18. So now I have 3 times 18. If you don't know this, don't be afraid to go off to the side here. It's just as easy as this. So 3 times 8 is 24. 3 times 1 is 3, plus 2 is 5. So 3 times 18 is 54. So the value of 3 times y plus 8 when y equals 10 is 54. And that would be my answer. So again, I had to kind of like unpiece this part of the riddle first before I could even attempt to answer this part. So in the end, I come up with my answer of 54. That's page 1. I'm moving on to page 2, which is on the back side of page 1. There it is, number 11. Number 11 asks us kind of a scenario here with an equation. So it says Grayson can use the equation y equals 8 5/10 times x to calculate his pay, where y represents the amount of pay and x represents the number of hours worked. How many hours did Grayson work if he was paid $127.50? All right, so this is kind of a case where we have two variables, right? We have our x and our y. It tells us that y represents the amount of pay and x represents the number of hours worked. So I'm just going to rewrite this just to make it maybe easier to see. on our video. All right, if X is the number of hours worked and it says how many hours did he work, we're going to try to figure out what X is. Y is the amount of his pay, and it turns out the amount of his pay is $127.50. So I can just plug that number in. So now this should look a lot like those questions on the front. And we didn't have a whole lot of work to get there. It was just a matter of kind of understanding the problem and then filling it out here. So the thing keeping X from being alone is this 8.5. So I'm going to divide 8.5 on both sides. Okay, cancels out. I'm left with just X. Over here, I've got a problem that I just don't know. So I'm going to do some math off to the side. I have 127 and 5/10. Notice I'm leaving that 0 off. I could put it back on. Not a big deal. And then over here, I have 8 and 5/10. Whenever I'm dividing with decimals, I know that I need to move the decimal over. The copycat moves over, and then it floats up to the top into the quotient. So I have 85. Does it go into 1? No. Does it go into 12? No. I'm just leaving those blank spaces above. 85 does go into 127 one time. So that's 85. Now I can subtract. 7 minus 5 is 2. 2 minus 8 can't do it. I could borrow here, I guess. And that really becomes now 12 minus 8, which is going to be 4. I can bring down my 5. 85 goes into 425. Ooh, boy, I don't know. I'd have to guess and check. So I'll do that off to the side. Let's say, what's a good guess here? I'm going to say maybe 4 times. Let's just try that out. So 4 times 5 is 20. 4 times 8 is 32 plus 2. That's 34. Ooh, look at that. I'm kind of close. Let's try out 5 times and just see if maybe that gets me a little closer. So 5 times 5 is 25. 5 times 8 is 40. Plus 2 is 42. That's 425. Oh, look at that. Amazing. 5 times was kind of my ticket there. So 5 times is correct. 5 times 85 is the exact same. 425. I'm left with 0. I can bring down my 0, and I have just 0 there. So X equals 15, or I could say 15.0, or 15 and 0/10, but I don't need that 0.0 at all. So really, if I'm looking for how many hours did he work, X equals 15. So I could say that my answer here is 15 hours, because that's the number of hours he worked. Now I could always go back and plug this in, 15 here. If I take 8 and 5/10 times 15, my answer will be 127.50. I kind of know that because I did the work over here already. And if I just reverse that, it's the same thing. Looking at number 12. Now number 12, some people will look at it and say, oh, this is going to be super easy because we see a bunch of letter options. This is one where we're selecting all of the equations that have n equals 9 as a solution. So I wouldn't really say this is going to be an easy question. What we're really going to have to do is almost substitute in the value of n for every one of these and then solve them to see if they're correct. Now some of them we might be able to use a little bit of mathematical instincts here, and maybe right away we're going to look at them and say that can't possibly be. For our purposes, I'm going to try to solve all of them, and maybe you'd want to do the exact same thing on your test just to make sure that you're right 100% of the time. So let's take a look at letter A. It says 3n equals 27. So I'm going to go and plug in 3n, that's 3 times n, or 3 times 9 equals 27. So 3 times 9 is 27. Since 27 equals 27, A is correct. I'll go ahead and do letter B. Letter B says 24 divided by n. I'm going to rewrite that as 24 divided by 9 equals 3. Let me think. 24 divided by 9, is that going to equal 3? There's no way, because I know that 27 divided by 9 equals 3. All right, let's move on to letter C. I'll put it right here. It says 5 times n, so 5 times 9 minus 1 equals 43. All right, so this is kind of like a two-step here. I'm going to use my order of operations. 5 times 9 is 45 minus 1. That's going to be 44 equals 43. That's not right, so that's not going to happen. Letter D. This says n times 5. That's 9 times 5 equals 45. Well, that would be 45 equals 45. That's correct. So letter D is correct. We come to letter E. Letter E says 6 times n, or 6 times 9, equals 52. Well, it turns out that 6 times 9 is 54, so that's not going to happen. Letter F, it says 12 plus n, which is 12 plus 9, equals 21. Let me really think about this for a minute, because I don't want to get this wrong. 12 plus 9, that would be 21. So check it out. A, D, and E, and F are my answers. But again, on our test, be aware it could be more than just 3 answers that are correct. We want to select all the ones that are correct. Remember, when I got to letter B, I kind of knew that wouldn't work out. I would get like a decimal answer or a fraction. When I got to letter C, I knew that didn't work out because they weren't the same answers. Same with letter E. So it was very easy for me to see the ones that did not fit or did not qualify. Moving on to number 13. Oscar recorded his walking pace in the table below. Which equation best represents this relationship? So check it out. I kind of have 2 scenarios here. I have a h value of 2.5 or 2 5/10, and an m value of 16 1/4 or 16 25/100. And then for the same thing, it has to work out that 6 and 39 go together. So it's almost like I can plug in my h and my m values to see which ones work. Keep in mind, if it works for one of them, it has to work for the other as well. So it might just, by a fluke, by an accident, kind of work out for one, but not both. It has to work for both. So let's take a look at letter A. I'm going to go ahead and, again, kind of like I did last time, sort of solve these by substituting, solving, and then I'll see what my answers hold. So I'm going to use my first numbers here to begin with. So I have m equals, that's 16.25, equals 2 5/10 plus 12.25. So if I add these together, I know that 25/100 and 5/10 is going to be 75/100. I know that 2 and 12 is going to be 14. So that's 14 and 75/100. So that does not equal out. That's a no for my first pair. I don't have to bother plugging in the 6 and the 39 because I know it doesn't work for my first set. So it's not going to work for the other one either. Or even if it does, it doesn't really matter because that's not the best equation for that relationship. Look at letter B. Let me try that one out. It says h, that's 2 5/10 equals 4 5/10 times 16 25/100. Now, I could go through and do the math here, but to maybe save some time, let's just think about it mathematically. If I'm trying to get an answer of 2 5/10, if I take a big giant number like 16 25/100 and multiply it by 4.5, I'm going to get something bigger than 16 25/100. It's going to be bigger than 2.5. I don't have to do anything here. I just can look at it and recognize that's not going to work out. Now, if I do the math there, I'll just kind of, I guess, affirm that thought, but I know for sure that's not going to happen. So we can use a little bit of common sense here as well. Take a look at letter C. M equals 6 5/10 times h. So I have 16 25/100 equals 6 5/10 times 2 5/10. Now, this is something where, again, we can always break this off to the side and do the math, which is what I think I'm going to do here, just because I'm not feeling ultra confident that I can do this in my head. So 5 times 5 is 25. 5 times 6 is 30 plus 2, that's 32. Add my placeholder 0, 2 times 5 is 10. And 2 times 6 is 12 plus 1 is 13. Add these together, 5, 2, 6, 1. There's one decimal move there, one decimal move there. So it's going to be, look at that, 16 25/100. I'm feeling really good here, but I've got to temper my emotions for a moment because even though I'm very, very excited about this, I want to plug in these other numbers as well, just to make sure those work also. So I have m. M here is going to be 39, and that's equal to 6 5/10 times 6. So let me try this. 6 5/10 times 6. 6 times 5 is 30. 6 times 6 is 36 plus 3. That's 39. There's one decimal move. So that's 39. That checks out. So it works out that letter C works for both of my sets, my H and my M here, and my H and my M here. I can go ahead and circle letter C because I know that's going to work out. But I also want to look at letter D just to guarantee that's not going to work. All right, just to make sure. So it says H equals, that's 2, this is letter D, by the way, 2 and 5/10 equals 16 and 25/100 minus 21. We'll take a look at this. If I have 16 and 25/100, I take 21 away, I'm going to be into like the negative numbers. So I know, again, I had a good thought that it was already letter C, but now I know for sure it can't be letter D. So letter C it is. And again, notice how I had to plug it in for both sets. That's very, very important. Don't get caught up if one happens to work out for one of them. Don't get hooked, I guess. Make sure you work it out for all the problems. Hey, let's move on to number 14. Number 14 says, tell whether 3/34 is a solution of y equals 9x plus 7 and show your work to justify. Now, I think before this chapter, you would have looked at a question like this and you would have just been lost and confused. But luckily now, when we see numbers here in parentheses, we think of that as an ordered pair. We think of that as an x and a y value. Remember all of our work graphing things on a coordinate plane, thanks to our focus work and our work during chapter 6. So I know the x value is going to be 3, and I know the y value is going to be 34. So with this in mind, this is really just a matter of me substituting and solving. This is like a pretty easy one. So I have y equals, that's 34 equals 9 times 3 plus 7. That's just my substitution step. Now I can begin to solve. Again, the left side of my equation is just 34. There's nothing I can do to solve 34. It's alone already. So the real work is on the right side of my equation, and I want to use order of operations. So I'm going to multiply first. 9 times 3 is 27. And then over here I have 34. I'll just bring that down. 27 plus 7. That's going to give me 34. And again, I could do that math off to the side if I need to. So check it out. It says, tell whether this is a solution. I've got 34 equals 34. So now I can answer by saying yes. And I put a little exclamation point there because I'm just so pumped up and excited about the fact that they are equal. Hey, that's our first page. Moving on now to number 15. Again, you'll notice like a lot of repetition going on here throughout this study guide, throughout a lot of the questions. They all kind of appear differently, but in the end, we're doing a lot of the same work, a lot of that substitution, solving, and answering. Take a look at number 15 with me. It says the rectangle shown has a length of 19 inches and a perimeter of p inches. Which equation could be used to find the width of the rectangle? Well, I know the perimeter. Perimeter means it's the measurement of the outside, right? All these sides together added up are going to equal p. So when I look over here at all my options, they say p equals, the perimeter equals. Well, I know this is w, so this has to be w. And this is 19, so this is 19. It's like they're just adding together all the sides. I could think of that as one big expression here. 19 plus w plus 19 plus w. If I simplify this expression, and this kind of goes back even to chapter 5, where we're talking about expressions, I can combine my two 19s. 19 plus 19, that equals 38. And then I have a w plus a w. I can combine those, they're like terms, into just simply 2w. So if I look over here, this would be my simplified expression of this perimeter. So I have a, that says 38 plus w. Well, if we do that, we're missing an entire side, a w side. So it can't be a. Letter B says 19 plus 2w. There again, we've got 19, we've got the 2w, but we're missing another 19. So it can't be B. Letter C, it says 38 plus 2w. Hey, that sounds familiar. That's what we said it was earlier, and that is our answer. And finally, letter D, just to make sure, it says 19 plus w. That would only be this side and this side. They're like missing out on half of the perimeter here, so it can't be letter D. So number 15, on the surface, you look at that and think, ooh, this is going to be really tough. I'm hoping that one's a pretty easy one for us, where we're just adding up all the sides and really just simplifying an expression. Look at 16. It says, find the value of h. Write the formula, show your substitution, use an appropriate label on the answer. All right, so it's basically spelling everything out for us. So we want to know what h is. We want to write a formula, show our substitution, and add our label. Well, we know the area is 54 square feet. We know the base is 9, and the height is an unknown h. I'm thinking of a formula that we know and love already. It's area equals base times height. Now I'm just going to substitute the values that I know. Area, well, that's 54 square feet. Base, that's 9 feet. Height, don't know it. It's just h. This problem now I can actually solve, which goes back to that first page, those really easy questions that we had on the first page. That's what we've got right now. We just had to do a little bit of work to set it up. So what's keeping the h from being alone? This 9 times h. So I'm going to use my inverse operations, and I'm going to divide away the 9 on both sides. That 9 cancels out. I'm left with just the height. 54 divided by 9, that's 6. So the height equals 6. Now here's where we have to be careful because it says use an appropriate label. If it's 54 feet squared, the base is listed as feet. Our height will also be feet. So it's 6 feet. The height is 6 feet. Again, I can go back and I can plug that in. I'm going to say 54 equals 9, and now instead of h, I'm going to say 6. 9 times 6, that's 54. Check it out. I know for sure I've got number 16 correct. That's how so many of these questions are. So you can turn in your test and immediately know how well you've done. Look at number 17. Again, you're going to look at this and you're going to say, ooh, this one's really tough. Can't figure it out. I don't want to try it. Can't do it. Stop that nonsense and instead just read the question, because this is another easy one. It says the length of garden B, here it is 7 more than the length of garden A. I'm going to underline 7 more. That seems important. This length is 7 more than this length. We want to find the length, I guess that should say x, of garden A. So we want to figure out the length of garden A. Well, to do that, I can just say 12, the length of garden B. Since I know that this is 7 more than this, I want to think inverse operations. I'm going to subtract 7 away from it. So 12 minus 7, that's going to give me 5. So garden A is 5 feet. That was so easy. And all I had to do was just read it. Again, they give you the diagram to try to help you out. But really the key there is that word 7 more. We know 7 more. This is 7 more. So this has got to be 7 less than 12. Hey, check it out. We have completed part 1 of our test. Now the study guide continues right into part 2, but I want you to know that's all we're going to have for part 1 of the test. Part 2 kind of builds on where we left off. Just a lot of more of the same. So let's go ahead and take a look at it, starting with now number 1, which is number 1 for really part two of the test. All right, so it says the total number of hours, T, that Melly has practiced her flute after D days is modeled by the equation T equals 8 times D. I'm just going to rewrite that down here just because I feel like that's a very important thing that we need to know. Complete the table to describe this relationship, and we must show our work and complete the table to receive full credit. No problem there. So check it out. If it gives me the value of D, I just plug that in here, and then I can figure out the value of T. So I'll go ahead and do that. If D is 3, so T equals 8 times 3. If that's true, 8 times 3 is 24. So the value of T is 24. Just plug it into my chart. Let me set up again. T equals 8 times D, but now D equals 6. So T equals 8 times 6. That's 48. Let me plug it in. Boom, I'm moving right along. Now I've got a kind of a different one. Now I know what T is. So it says T equals, that's 72, equals 8 times D. I don't know what D is, but this is just like all those other questions. I look and see what is keeping D from being alone. It's this fact that it's being multiplied by 8. So I'm going to divide away 8. When I do that, the 8's cancel out. I'm left with D on one side. 72 divided by 8, that would be 9. So I plug that into my chart, 9. That's as easy as it is. Number 1, that's all I need to do. It's almost like it gives me the values here of 3 different options. I plug them in 3 times and solve and add to my chart. Moving on, take a look at number 2. It says your friend has Z baseball cards. You have 51 baseball cards. You and your friend have a total of 108 baseball cards. Write an equation you can use to find Z. So all I need to do here is write an equation. Okay, so I'm not getting credit for like finding Z. I just want to write an equation to find Z. So it doesn't matter. I could say Z is 12, and if that's the right answer, I'm getting 0 points. I want to know how to find Z. There's multiple options because we know we could write equations a couple different ways they could work out to work that way. So if I have 51, my friend has Z, we both have a total of 108. I'm going to go ahead and say the total 108 is going to be the sum of both of our collections. And I'm just going to say Z plus 51. Now I could also have said 51 plus Z equals 108. I could say 108 minus 51 equals Z. I could say 108 minus Z equals 51. Again, a lot of variations on that, but as long as you've got one of those options and as long as it makes sense, then you're in good shape. Number 3, kind of similar. It says write the word sentence as an equation. We're not solving, we're just writing the equation. It says 6 less than, keywords, 1/4 of a number X is equal to a number Y. So I know it's going to say is equal to Y because that's taken right from the words. Here's how I've got the keyword, 6 less than 1/4 of X. Remember, of means times. And less than means minus, but this is the one where it's going to switch in order. So we're not going to say 6 minus 1/4 times X. We're going to say 1/4 times X minus 6. Gets kind of tricky there. So we want to make sure we're not getting that mixed up. So 1/4 of a number X, 1/4 times X minus 6. Look at this closely now. This says 6 less than minus 6, 1/4 times X is equal to Y. So this is the correct equation. Now up here on number 2, there were like multiple options. Down here, there's really only one option that we can use. This is the only way to write this, I guess. Well, now technically you could say X times 1/4, that would work as well, or 1/4 times X, but we need that minus 6 after that in order for that to be accurate. Let's move on. We've got a little chart on number 4. We've got the rate of snail movement. And on this chart, it says a snail is trying to get to the other side of the park. At what rate is the snail traveling? Write a formula, show your work, and use a proper label. So it looks like there's been a misprint on this study guide that I'm looking at here. This actually should be right here at 0, 0. This should be at 3, 5. And this should be at 610. So it is at 610 there. So my line is a little bit off. It looks like it should go up like this and connect that way. All right, so hopefully that'll be corrected by the time you get your study guide. And I apologize for the error here on the video. But at any rate, the locations here, the coordinates, are listed right here. And that's kind of intentional to help you out. So we know that the rate is determined by the distance formula. We could think of distance equals rate times time. Or a lot of us remember that as the dirt formula, because it almost looks like the word dirt. D equals RT, dirt. Right? So if distance equals rate times time, we have the distance, feet, here going up. We have the minute, or the time, going side to side. Remember, this is our X, this is our Y. So if that's the case, we can plug that into our distance formula and figure out what that rate would be. So I'm going to do that maybe with some of our options. Now, I'm not going to use 0, 0 for a really important reason. It's not going to work out every time. It's going to be 0. Like, there's not much of a point to that. So I'm going to use maybe my 3, 5 or my 6, 10. And just to make sure, what I'm going to do on my video here is show you both of those, and it's going to work out the same each time. You could do that on your test as well, just to make sure that you're 100% accurate. So I've written my formula, the dirt formula. Now I need to just substitute and solve. So I'm going to substitute. I'm going to use the 6 and the 10 for now. Remember, 6, that's my x value, so that's my time. So I'm going to plug in the time as 10. The 6, that's my, or sorry, the 10, I just messed that up. Sorry, my time is going to be 10. I'm going to rewrite that over here on the side. Time is going to be 10 because that is the, wait, I had that right the first time. Oh my goodness. All right. So after a little bit of a mix-up here, I think I've got my calculations correct here. I think my chart is messing me up. All right, so distance equals rate times time. The distance is going to be the y value. If I use 6 and 10, that distance is going to be 10. So I can say 10 equals the rate times the time. I don't know what the rate is, but I know the time is going to be here, my x value, and that's going to be 6. So if I look at this, what's keeping the r from being alone? It's the time 6. So I'm going to divide by 6 on both sides. So if I do that, I'm left with r, and then I have 10 divided by 6. Now I could just leave that as 10 over 6, or I could turn that into a mixed number. That would be 1 4/6, or I could simplify that down, which I probably should do. That'd be 1 2/3 would be the rate. Now, if I try this again, only this time I'm going to use my 3 and my 5, I could do the same thing. My distance, again, is going to be the y value. So that's 5. The rate, I don't know. The time, that's going to be 3. So in this example, I'm going to have, I'm going to have to get rid of that 3 by dividing away 3. I don't know why I put that 5 there. Got a little excited and went too quickly. So I'm left with r. R equals 5/3, or I could simplify that down into 1 2/3. Look, I got the same answer both times. Now here's where it's really important. It says we want to use a proper label. So the label here is going to be feet per minute, right? So it's 1 2/3 feet per minute. Another way to write that is feet over minutes, right? Kind of make it look like a fraction. Okay, so however you label that, or just pulling the labels right here, feet per minute, right? I believe it's going to be the exact same way on your test as well. Let's move on to number 5. We've made our way to the last page. This is exciting stuff. Number 5 says the equation T equals 7 times H represents the total weekly pay, T in dollars, for H hours of work. Identify the independent and dependent variables. So our variables are either going to be H or T. So this is really just like a 50-50 chance. I can just plug them in. But rather than do that, we might as well be accurate. So you think about this, independent variables are the ones that can change. Dependent variables are the ones that depend on that changing variable. So in this equation, if you think about it, the total is going to change depending on the number of hours that are worked. If you work 0 hours, you get $0 total. If you work 1 hour, you get $7 total. So H is that independent variable, the one that can change. The T, the total amount of dollars, that really depends on the number of hours. Okay, so if that's the case, our independent variable is going to be H. Our dependent variable is T. That's all we need to do to solve that problem. That sounds so simple, but it's really a matter of like really understanding how this expression works, how this equation works, and how those two H and T's, I guess, interact with each other to know which one's the independent variable, which one's the dependent variable. Moving on, take a look at number 6. The table shows the costs of playing several carnival games. You have $35 and play each game 3 times. How much money do you have left? Well, there's really a lot of ways we can answer this. We can actually set up an equation to do this, which may be a great way to do it. Some of you may prefer just to like multiply each of these by 3, add them up by getting a total, taking that sum and subtracting that from 35. That would work as well. All right, I'm going to set it up here on our study guide and on our video as an equation. So I have $2.50 to play ring toss. I want to multiply that by 3. I'm going to put that into parentheses because that's a total there. I'm going to add that then with $3.25, times 3, because I play that game 3 times as well. I'm going to add that with $4.50 times 3. Now just think about that. That tells me the total for ring toss, balloon pop, and basketball, playing each of those 3 times and adding that all together as one big sum. Next, what I want to do then is take that big sum and figure out the difference between 35. So I'm going to go back over here. I'm going to say 35 minus that. Now if I do that, the only problem is order of operations is going to say I have to subtract first because it's coming first. So I'm going to put all these in parentheses. This gets a little bit crazy and tricky. If you're trying to set this up and it doesn't make sense, then this may not be the way to go with you. You may want to just, multiply by 3, by 3, by 3, add together, subtract from 35. There's no right or wrong way to answer this as long as we're doing the correct math. So if I solve this expression now, I'm going to have my sum of playing all the games 3 times, take that total minus my amount that I have, $35, and that'll tell me how much money I have left. So if I use this expression. All right, so 250 times 3. Let's see if I can do this in my head for a second here. 250 times 2 is $5, and then another 250, that's going to be $7.50. Then I have 325 times 3. Boy, I just impressed myself so much there. Let's see if I can do it again. So I have 3 times $3, that's going to be $9, and 3 times 25 cents is 75 cents. That's $9.75. Again, I don't recommend doing this in your head unless you'd like to. Always take the time to do the work that you need to do to get it right. Then I have 450 times 3. Let's see here. 450 times 2, that's going to be $9. And then another 450 on top of that, that's going to be $13.50. So I'm going to add all those. Again, remember these parentheses on the outside there. So those are still in parentheses. So now I have 750 plus 975 plus 1350. All right, I'm going to break down and just go ahead and do the math off on the side here. Adding this together. This kind of reminds me a little bit of work we do during computation practice, I think. All right, so we get 7 plus 10, that's 17. Drop down my decimal point. Now I have 13 plus 7, that's 20, and that's $30.75. So I have 35 minus $30.75. So I should come up then with $4.25 left. So how much money do I have left? I got $4.25 left. Again, all this question really asks us to do is kind of doing some math. I set it up in a big expression. You can solve this however you'd like to, but keep in mind there's a lot of numbers going around there, so you want to keep it all organized and straight for yourself. Let's move on to our final question, number 7. Here we get a graph, it's blank, and we're going to have to fill that graph in. So it says, show the relationship between the time and the distance traveled. Be sure to label each axis. So I will do that. So I have time and distance. So kind of like what I did here, bringing back my snail question, I can actually use this, since it's on the exact portion of our test, to kind of help me out with number 7. Because if you look at it, it's kind of the same thing. So they've labeled our distance was here and our time was here. So I'm going to go ahead and put my time as hours because it says hours. And the distance, I'll go ahead and say, is miles. So I've labeled my 2 axes. All right. And then it says that I'm just going to plot these points. Now the problem that you're going to find is, like, if I try to say this is going to be like 1 hour, 2 hour, 3, 4, 5, 6, 7, 8, 9. I'm good because I've got up to 8 hours. So I can do that. I can say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But I can't do that with distance. I can't say this is 1 mile, 2 miles. I'm going to run out of miles really quick because I have to go all the way up to 180. So I have to think about how to label this best so that way I can fit everything onto my chart. Okay, and some people get hung up on this because they think, well, if I did it by ones down here, it has to be listed by ones here, and it doesn't. So let me think. I could do, let's say, by 60s, I guess, right? 60, 120, 180. That would work. I could do that. I could do by maybe tens. Let's see. Nope, tens won't work, but I'm going to run out of space. I get to 100 and stop. Maybe 20s. 20, 40, 60, 80, 100, 120, 140, 160, 180. That would work. So maybe I'll do 20s. All right, so I've got my labels. That's kind of a key thing, just labeling this correctly. Now it's just a matter of plotting points. So I have 0, 0. Well, that's easy enough. Right here is 0, 0. Then I have 2, 60. Now keep in mind, on my chart, I go over 2, because that's where 2 is, and 60 is only going to be up 3 spaces. So right there is 260. I'm going to number that, actually, just so I remember that one, and I should probably do the same for 0, 0. The next one I have is 8 and 180. So I'm going to go over 8 and then up to 180, which is actually up here. So if you need to draw little lines lightly with pencil, you can do that. So that would be 8 and 180. Now the last thing I need to do is I want to make sure that I draw a straight line, or as straight as I can, between my points. Right? So that kind of goes through there. So that's all I need to do. I'm just graphing to show the relationship. There's really not a lot of math going on here. I didn't have to add, subtract, multiply, or divide. I just had to label things correctly, plot out my points correctly, and then draw the line to connect the dots. And that is number 7. That's actually the last question on part 2 of our test and the last question on our study guide. So for chapter 6, lots of questions to kind of go over, but you notice the repetition that's taking place. A lot of doing the same types of things over and over again. So good luck as you prepare for the chapter 6 test. Please make sure that you are preparing so that you can be ready and you can do your very best. Good luck.